Hello students, today's topic is cumulative distribution function for continuous random variable. The cumulative distribution function fx for a continuous random variable x is defined for every number x by this form, that is fx equals to probability of random variable x at most x. For each x, fx is the area under the density curve to the left of x. As you can see in this figure, let's suppose x equals to 8. So f8 is the area below the density curve and to the left of 8. That means this area. Fine. Using CDF to compute probabilities. Let x be a continuous random variable with PDF fx and CDF. Then for any number a, probability that x greater than a will be equals to 1 minus probability x less than and equal to a, that means 1 minus fa. And for any two numbers a and b with a less than b, probability that a less than and equal to x less than and equal to b will be equals to fb minus fa, as you can see in this figure. Obtaining PDF from CDF. If x is a continuous random variable with PDF fx and CDF, then at every x at which the derivative f dash x exists, derivative of CDF will be equal to PDF. Now let us start with this question. Here we have given this function fx equals to 3x square for 0 less than x less than 1. First part is show that fx represents a density function. Solution: it will represent PDF if integration of fx ranging from minus infinity to infinity will be equals to 1. So let us consider integration minus infinity to infinity fx dx. In the next step we will write integration. Limits have been given as 0 to 1, so we will write 0 to 1, fx is 3x square. So 3x square dx. In the next step, 3 times x cube upon 3, and the limits are 0 to 1. This will be cancelled out. Next step, 1 cube minus 0, and the final answer is 1. Therefore, the given function is PDF, probability density function. Fine. Second part, find probability that x lies between 0.1 and 0.5. So B part, probability 0.1 less than x less than 0.5 equals to integration 0.1 to 0.5, function is 3x square dx. Now you can solve it further. C part, find CDF, cumulative distribution function. Case 1, x lies between minus infinity to 0, that means in this range. So CDF in this case can be found out as minus infinity 2x, and the PDF for this range will be 0. So the answer is 0. Case 2. When x lies between 0 and 1, that means in this range. So CDF will be minus infinity to 0 plus 0 to x, and the PDF for this range is 3x square. So we will write 3x square dx, and the final answer will be x cube. Case 3. When x is greater than 1, that means in this range, fx will be equal to minus infinity to 0 dx plus 0 to 1 3x square plus 1 to x. Again, the PDF for this range will be 0. So the final answer will be 0 plus 1 plus 0, that is 1. The entire CDF is when x is less than 0, fx is 0. When x lies between 0 to 1, fx was x cube, and when x is greater than 1, fx is 1. Fine. Last part. Find median Q1, that is first quartile, third quartile, and 90th percentile. So let's start with median. Median is a point which divides the whole distribution in two equal parts. That means this area denotes 0.5 and this is also 0.5. So we can write probability that x less than and equal to median is equal to 0.5. In the next step we can write it as fm equals to 0.5. In our case fx was x cube, so we will write m cube equals to 0.5, and in the last step median equals to 0.5 raised to the power 1 by 3. Next one is first quartile. The first quartile denoted by Q1 means that about 25% of the numbers in the data set lie below Q1 and about 75% lie above Q1. That means this is 0.25 and this is 0.75. So we will write probability that x less than and equal to Q1 equals to 0.25. That means this area. In the next step, fq1 equals to 0.25, q1 cube equals to 0.25, and last, the first quartile will be 0.25 raised to the power 1 by 3. Fine. The third quartile denoted by Q3 means that about 75% of the numbers in the data set lie below Q3 and about 25% lie above Q3. That means this area is 0.75 and this is 0.25. So we will write probability that x less than and equal to Q3 equals to 0.75. That means this area. In the next step, fq3 equals to 0.75, q3 raised to power 3, that is cube, equals to 0.75, and last step, third quartile will be 0.75 raised to the power 1 by 3. 90th percentile. So this area will be 0.9 and this is 0.1. We will write probability that x less than and equal to p equals to 0.90. That means this area. Next one is fp equals to 0.9, p cube equals to 0.9, and at last 90th percentile will be 0.9 raised to the power 1 by 3. Fine. Now the next question is, Find the probability density function for the random variable whose distribution function is given by this form and plot its graph. So we have given this CDF and we need to find PDF. So PDF will be equals to derivative of CDF, that is f dash x, which will be equals to derivative of 0 with respect to x will be 0 for this range, that is x less than and equal to 0. Derivative of x with respect to x will be 1 for this range, that is 0 less than x less than 1, and last derivative of 1 with respect to x will be 0 for this range, that is x greater than and equals to 1. So here we have PDF. Now we will plot its graph. We have taken x on the horizontal axis and PDF, that is fx, on the vertical axis. Now first one, when x is less than and equal to 0, fx is 0. So that means this range. Next one, when x lies between 0 and 1, fx is 1. That means this range. When x lies between 0 and 1, fx is 1. This range. And when x is greater than and equal to 1, fx is 0. That means this range. So this is the graph of PDF. Fine. Next question. We have given this function and the range is 0 to 1. First part, check the above function is PDF. It will represent PDF if integration of fx ranging from minus infinity to infinity is equal to 1. So we will consider integration minus infinity to infinity fx dx. In the next step, integration 0 to 1, and fx is this one, which is 6x 1 minus x dx. In the next step, integration 0 to 1, it will be 6x minus 6x square dx. Next step, 6 x square by 2 minus 6 x cube by 3, and the limits are 0 to 1. It will be cancel out. Next step, 3x square minus 2x cube 0 to 1, 3 minus 2, which is equal to 1. Therefore, given function is PDF. Fine. Next part, find CDF. Case 1, when x lies between minus infinity and 0, that means in this range. So fx or CDF will be equals to, function for this range will be 0. So the CDF is 0. Case 2, when x lies between 0 and 1, that means within this range, CDF will be equals to plus, and the function for this range is this one, which is 6x minus 6x square dx. It will be equals to 0 plus, and this will become 6 x square by 2 minus 6 x cube by 3 0 to x, and this will become 3x square minus 2x cube. Fine. Case 3, when x is greater than 1, that means in this range, so fx will be equals to plus 1 to x, and the function for this range will also be 0. So the answer is 0 plus 1 plus 0, which is equal to 1. The entire CDF is this one. When x is less than 0, CDF is 0. When x lies within this interval, that is 0 and 1, fx is 3x square minus 2x cube, and when x is greater than 1, CDF is 1. Next part, find this probability, that is half less than and equal to x less than and equal to 3 by 4. So probability half less than and equal to x less than and equal to 3 by 4 will be equal to probability x less than and equal to 3 by 4 minus probability x less than and equal to half, which is equal to f3 by 4 minus f1 by 2. So fx was 3x square minus 2x cube. It will be 3 by 4 square minus 2 3 by 4 cube minus 3 1 by 2 square minus 2 1 by 2 cube. Now you can solve it further. Last part, find this probability. Remember, probability of A upon B is equal to probability A intersection B upon probability of B. In the same way, we will calculate this as probability of x less than and equal to half intersection 1 by 3 less than and equal to x less than and equal to 2 by 3 whole upon probability of this term. Fine. Now the question that appears in my mind is, how will we calculate the intersection of these two terms? Let's consider this one, x less than and equal to half. That means this portion, right? And the other one is that x lies within the closed interval of 1 by 3 and 2 by 3. That means this area, correct? And now we need to find the intersection of this region and this one. So the intersection area will be this one, 1 by 3 to 1 by 2. So I will write probability 1 by 3 less than and equal to x less than and equal to 1 by 2. Fine. Upon denominator will remain same, that is probability of 1 by 3 less than and equal to x less than and equal to 2 by 3. Now first we will calculate this numerator part. Probability 1 by 3 less than and equal to x less than and equal to half will be equal to 1 by 3 to 1 by 2, 6x 1 minus x dx. In the next step, we know that its integration was 3x square minus 2x cube, and the limits are 1 by 3 to 1 by 2. In the next step, 3 1 by 4 minus 2 1 by 8 minus 3 1 by 9 minus 2 1 by 27. This will be cancelled out. 3 by 4 minus 1 by 4 will be equal to 2 by 4, that is 1 by 2 minus 1 by 3 plus 2 by 27. In the next step, we will take the LCM. 54 27 minus 18 plus 4, which is equal to 9 plus 4 13 upon 54. So we will write 13 upon 54 whole upon. Now we will calculate this probability. Probability 1 by 3 less than and equal to x less than and equal to 2 by 3, which will be equals to integration 1 by 3 to 2 by 3, 6x 1 minus x dx. In the next step, 3x square minus 2x cube 1 by 3 to 2 by 3. So it will be 3 4 by 9 minus 2 8 by 27 minus 3 1 by 9 minus 2 1 by 27. So this will be cancelled out. We will write 4 by 3 minus 16 by 27 minus 1 by 3 plus 2 by 27. 4 by 3 minus 1 by 3 will be 1, and this will become minus 14 upon 27. That means 13 upon 27. 13 upon 27. So after solving this, we will get 1 upon 2. Fine. Thank you.